Hello, ladies. I have decided, if you watched the previous video, you would know it's late in the day. I'm tired. I'm ready to go for a walk. I've been on my bottom since 7:30 a.m. and it's now 4:30, but I want to power through and just do one more video. So I apologize in advance if I waffle on, but I think I waffle on all the time. But if I make mistakes, please be understanding, but I think it's better. Oh, there we go. First mistake. Can't even write the number 7. I know that when I come back from my walk, because I find it so relaxing that I don't want to come back to work. So I'm doing it now just in case I feel like I don't want to come back. All right. So the previous video covered 1 to 6. Now I'm going to just do 7 to 10. I think that's realistic for me. It'll probably give me a good chance to stop talking after I've done question 10. Okay, let's move on. So question 7, 100 metre square hay shed is to be extended to give 475 metre squared of floor space in total as shown. All angles are right angles. Find the value of x. So here we've got the original hay shed and we've got an extension here. Okay, so we're going to give 475 in total. So it's not an additional 475, it's 475 in total. All right, I'm going to draw the diagram just because I'm so good at it, and I know you probably love watching me fail at drawing diagrams. Okay, so we've got this beautiful square here, and it's a 10 by 10, and the area is 100 meters squared. Okay, good. And this length here, which obviously is not drawn to scale, this is x and this is x. All right. Now we've got two shapes here, and they're both, one's a square and one's a rectangle. So let's write a formula for that area. So you can say we've got a rectangle plus a square. Okay. The full area has to be 475. The rectangle is going to be x on the bottom here. So length times width, x times x plus 10. Okay, so this is x here, and then we've got the additional 10 there. So it's x times x plus 10. And I'm sorry, I'm a bit squishy there. And we've got a 10 by 10 there, which we already know is 100. Okay, we already know the area of that square. I'm going to write it down here because I feel like I'm just a bit squishy there, and sometimes my handwriting isn't the best. So x times x is x squared. X times 10 is 10x. And then we've got plus 100. Now let's bring everything over to one side. So obviously I'm going to subtract that 475 from both sides. So let's write it down. So it's going to be minus 375. Now you could probably do that on your calculator if you're a bit unsure. So now we need two numbers when multiplied together give you 375, and when negative 375, and when added give you 10. So I always like to set up, it's kind of like, well, I don't know what those two numbers are just yet, but I know there's going to be x's there, and I know one has to be a positive and one has to be a negative because this is a negative here. All right, let me just think. Can I think of anything? What is, no, that number's too high. All right, I'm just going to quickly see what I can get on my calculator. 15 and 25, awesome. Isn't it great when it's the first number you actually plug into your calculator? So 25 and 15 are our two numbers. So using the null factor law, just separate your brackets. So we've got x equals negative 25 and x equals, that's a negative 15, so it's positive 15. I didn't know whether that was a plus 5. Okay, now, as we've been doing, if we're working with measurement, we can't have a negative number. So we've got to have x equals 15, and that's all we have to do. We have to find the value of x, which is awesome. All right, we can check our answer if we need to, but I'm not going to because I want to keep this video short and I also want to go for a walk before it gets dark. How selfish of me. All right, solve for x in these right-angled triangles, and it's told us to use Pythagoras' theorem. So we're not doing the area this time, whereas in the previous examples, in the previous questions in the previous video, we did the area. This time we're just looking for x. Okay, so we're finding the value of x. All right, so Pythagoras' theorem, just because I like colors, let's just write that in green. A squared plus b squared. Gosh, oh my God. Equals c squared. I had a blank then. But a squared plus b squared equals c squared. Awesome. Okay. So it doesn't matter what your A and your B are, but your C has to be your hypotenuse, the length opposite your right angle. All right, so let's put them in. So I'm going to do x first. So x squared plus x plus 2 squared. Make sure you put that in brackets. Equals, I was going to write C, but it's 10. Fix that up quite easily, didn't I? All right, so when we expand this, we're going to get, and I'm going to not do every step involved, but I'm going to have x squared plus 4x plus 4. And then I'm going to bring that 10 over. So 10 squared is going to be minus 100 equals 0. There's a lot going on there. All right, let's tidy it up. We've got, so we look at our like terms first. So we've got 2 lots of x squared here. So we're going to have 2x squared. Then plus 4x. And then plus 4 minus 100, so we're going to have negative 96. All right, now the easiest thing to do now is to get rid of this 2. So if we divide everything by 2, okay, so remember if we're getting rid of this 2, every term has to be divided by 2. Okay, it's just not this and the 0. Don't forget the 4x and the 96. So now we've got x squared plus 2x minus 48, it's about to write 49, equals 0. 0 divided by 2 is just 0. All right, let's set up our brackets to equal 0. Then we've got x. Okay, this one is negative, so that means one has to be negative and one has to be positive. 2 numbers when multiplied give you negative 48, and when added give you 2. Now I know that's going to be 8 and 6. Nice easy ones for me. Scroll, scroll, scroll. Okay, so now we've got x plus 8 equals 0. So x equals negative 8. And x minus 6 equals 0. So x equals 6. Now, we are still dealing with side lengths, so we can't have x equals negative 8. So the only solution you can have is x equals 6. All right, I might do C. I might skip B just because it's the same thing, but C does look a little bit tricky with those negatives in there, or negative. Okay, so x minus 2, x plus 1, and 9. I'm so thirsty from talking too. So if you hear me having a break, it's probably because I need to have a drink. Okay, so your Pythagoras' theorem I wrote before, a squared plus b squared equals c squared. So let's write that down. Now remember, you have to put brackets around it. Don't forget your brackets. So there's my a, my b is 9, and c, remember, is always your hypotenuse. So x plus 1. We're going to square that too. All right, let's expand these brackets. So when I expand x minus 2, I'm going to have x squared minus 4x plus 4. Then we've got the 9 squared, which is 81. And let's expand this. We're going to have x squared plus 2x plus 1. All right, let's tidy everything up. I will have a drink, actually. Okay, so, let me just check that everything is right, because I notice that my x's are going to cancel each other out. All right, let's just go ahead anyway. So if I bring that x over, it's going to be minus x squared. So that actually cancels out with that. Then I've got, oh, I probably shouldn't leave the negatives, but I will do it for now. So that 2x has come over by subtracting 2x to both sides. And then that 1 it's going to come over as -1. And then I've got plus 4 plus 81 equals 0. So let's tidy things up. So minus 6x. -1 plus 4 is 3, so plus 84. So I'm going to have 6x equals, now you can just do it this way, 84, divide both sides by 6. So I've got x equals, oh my gosh, let me just think. I'm having a blank. What is that, 12? No, 10. Oh my gosh. How embarrassing. Let's just quickly do it. 14. Just make sure I plug that into the calculator correctly. All right, and there we go. X equals 14. And you can always check your answer if you need to. So just one solution there. All right, might move on now to question 9, or I'm tempted to do 11 as well because I just noticed then that we're moving on to the reasoning section. Okay, I might do that. Okay, question 9. Let me just write the number 9. Okay, a square hut of side length 5 meters is to be surrounded by a veranda of width x meters. Find the width of the veranda if its area is to be 24 meters squared. Now, this is we've got a diagram here, which isn't entirely helpful because even though it's a hut, we don't need to draw the hut like that. Think of the hut as seeing the hut from a bird's eye angle, so from above. So there's your hut. Okay, it is a square hut. So we're looking at it from the sky. So pretend there's a little birdie flying over this hut, and that's what it sees, a square. And has a side length of 5 meters. So it's 5 meters all around. And it's surrounded by a veranda. So let's put that veranda on. And is x meters. So this distance here is x, and the same as this one here. Okay, all around it is x meters. Find the width of the veranda if its area is to be 24. So we want the area of the veranda. Let's make sure I can spell veranda right. Is 24 meters squared. All right, so let's have a look at how we can calculate the area of the veranda. And just because I want to, I might color it in yellow because, no, why not? Okay, so we want to find the area of that yellow part, and let's make our hut grey because that one, it looks grey. Okay, so there's our hut in grey. Obviously not a square, but I feel like if I, oh no, I'm not going to color over the black, which is good. Oh, good job. Okay, so there's our hut and the yellow veranda around the outside. Now, what we effectively want to do is take this big rectangle, okay, and take away this, not rectangle, it's a square, this big square, and take away this smaller square. So we need to work out the length of this. Now, I know that the hut is 5, and this side here is x, and this side here is x. So this whole length is going to be 5 plus 2x. So the area of your veranda on the outside is going to be 5 plus 2x squared, okay, because it's a square. Now we're going to subtract the area of the hut, which is 5 squared. All right, so let's just tidy things up a little bit. Now the area had to be 24, so I can put in 24 here. I'm going to expand this bracket. Now I should have really written 2x first, so I'm going to cheat a little. Actually, oh, I shouldn't do that because I feel like I'm going to make a mistake. 10, 20x plus 25 minus 25. Okay. All right, let's tidy up a little bit. Oops, no, that's disappeared, sorry. So we've got 4x squared. Oh, let's put everything on one side. Minus 24 equals 0. Now, if you've got a coefficient of x squared, and you can't see me, but I'm actually doing hand signals with my hands. Okay, we've got a coefficient of x squared. Think about if you can get rid of it by taking out a common factor. So we've got 4 here. We can actually divide everything by 4, which is awesome. So it turns quite an annoying quadratic into some of you might think not so annoying or a friendly quadratic. What about 5x? And then minus 6 equals 0. Okay, so let's factorize. So two numbers when multiplied give you negative 6. So one's going to be positive, one's going to be negative. My two numbers, 2 and, no, sorry. What are they going to be? 6 and 1. 6, positive 6 and negative 1. So we're going to have x plus 6 equals 0 or x minus 1 equals 0. So x is going to equal to negative 6 and x is equal to 1. Now we can't have a negative width of our veranda, otherwise it wouldn't exist. So we have x equals 1. All right, and okay, I was just thinking whether to do something, but it's all good. All right, question 10. Oh, these questions always stump people. All right, a father's age is the square of his son's age. So let's say the son is x and the father is equal to the square, so x squared. In 20 years' time, just thinking, in 20 years' time, the father will be 3 times as old as his son. So let me just think. So we've got in 20 years, so that's their current age. So in 20 years, the son will be his current age plus 20, and the father will be his current age plus 20. So let's just say the son was now 6, the father would be 36. In 20 years' time, the son would be 26, and the father would be 56. All right. So in 20 years' time, the father will be 3 times as old as his son. So the father's age, x squared plus 20, is equal to 3 times the age of his son. Okay, so the father's age is going to be 3 times as old as his son. What are the ages of the father and the son? So we've just got to solve for this, solve for x. Okay, so we've got 3x plus 60. Let's just tidy everything up a bit. Okay, so we've got x squared. I'm going to bring that 3x over, minus 3x plus 20 minus 60 equals 0. Okay, so my two numbers are going to be 8 and 5. So x, and one's going to be positive, one's going to be negative. So positive 5 and negative 8. Okay, so we've got x plus 5 equals 0, x minus 8 equals 0. So x equals negative 5, x equals 8. Now, obviously, the son can't be negative 5. So the son is 8. And the dad is 64. So the dad must have started a bit later in life. Maybe I just want to check the answer. All right, that's okay. You can obviously have a child when you're 56. All right, so let's move on to, we'll do question 11. I know I said I'd just do 10, but 11 finishes off the problem solving section. So a rectangular painting is to have a total area, including your frame, of 1,200 centimeters squared. If the painting is 30 centimeters long and 20 centimeters wide, find the width of the frame. So let's draw our diagram. Okay, so here's a nice painting of a sun over some mountains. And then we've got the frame going around it. Okay, so we know that the painting is 30 centimeters long and 20 centimeters wide. So this is 20 and this is 30. Oh, it's a terrible 3, but I might just fix it up a little bit. 30. And we know that the total area is equal to 1,200. Now, we don't know the width of the frame, so that's what we need to work out. And we're assuming that it's the same width all around. And I think we mean the width, this length here, not the total width. It's a bit hard how it's worded, but that's all good. Let's just go with what I think it is. And if we're doing the whole length of the frame, then we can deal with that too. All right, so our total area. So this whole length here is going to be 20 plus 2x. And then this length here is going to be 30 plus 2x. So the x coming from the length of the frame. All right, so the area formula is length times width. So let's just substitute in what we know. And 20 plus 2x. Okay, so we just need to expand those brackets. Okay, so I'm just used to doing the x's first, so I'm going to do that, but you should know how to expand brackets by now. I said that as I'm about to just, okay, 60, 40, so it's 100x plus 2 times 3, 600. Gosh, I should very much check that I've done that right. So 2x times 20 is 40x. 2x times 30 is 60x. Good. I don't know whether you can hear, but there's a noisy plane overhead. And I feel like I'm just writing the same thing again. Okay, I don't know why I did that. All right, so let's put everything onto one side. So we've got the 4x squared plus 100x plus 600 minus 1200 equals 0. Okay, I'm going to divide everything by 4. Remember, this makes things a whole lot easier for us if we can take out a common factor. Obviously, we're dividing that by 4, but it just stays 0. And we get x squared plus 25x minus 150 equals 0. So we need two numbers when multiplied give us negative 150, and when multiplied give us 25. I feel like I've made a mistake somewhere. I'm just trying to think as I go along. I might pause. All right, so we've got 30 and 5. So just separating your brackets and letting them equal 0. So we've got x equals negative 30 and x equals 5. So we're doing a painting, so we can't have negative 30 length of your frame. So the width of your frame is 5 centimeters. Okay, so we can just rewrite that as 5 centimeters. And we've done a great job, so let's give us a huge smile, and I'll see you later. Bye.